Example 6. A cone is resting on HP with its base and axis is parallel to VP. The diameter of base is 30 mm and axis is 65 mm long. Develop the lateral surface of the truncated cone if it is cut by a section plane inclined at 30 degree to the HP and 37 mm away from the base. Assume the cutting plane to be perpendicular to VP. So here we will just split this question. First, the solid given is a cone. It is resting on HP with its base and the axis is parallel to VP. Dia is given and the axis height is given. So the top view is a circle and front view is a triangle. And it is mentioned here we have to develop the lateral surface of the truncated cone. Truncated means a solid which has been cut. Here it is cone. So the truncated cone and the section plane is given at an angle 30 degree to the HP. So this is a case of inclined section plane and 37 away and the position of section plane is such that it is 37 mm away from the base. So this is an interesting question. Here you have to first draw the projections of the cone. Then you have to cut the solid at a distance of 37 mm from the base, inclined at 30 degree to the HP. Then you have to develop the lateral surface of the remaining cone. But what we will do is we'll just first draw the front view and top view, and we will develop the surface in such a way that it has not been sectioned or cut. Then we will apply the section plane and we will complete the development of surface of the leftover cone. So now we are having a cone as you can see on your screen, and we will assume we'll get the section plane. Here the section plane is now parallel, as you know it from the section of solid section, and this section is 37 mm away from the base as given in the question. It is inclined also, so I will make it inclined and also 37 at a distance 37. So let us say this is the angle, as you can see the inclined section plane, and it is 37 mm away from the base. So let us say this is the final position of the section plane, and we will visualize this. And as I mentioned, we have to assume this cone to be hollow. I'll just erase the bottom base to let you know that. As you can see now, observe it carefully. There is nothing inside this. We are having just the surface of this cone, and that too the truncated cone. That means the leftover cone. So when we view it from this side, this is not the front view. This is the side view. So when I view this from this side, you will be easily able to observe the truncated portion here, which will appear as a small ellipse above, as we did in section of solids section. You see that this is not a complete circle. This is kind of a ellipse. Now you can see I have highlighted that portion. Now we'll try to develop the surface, because now as the cone is cut, we just need to develop the surface. So I'll just take out some portion one by one. Now you can see that it is not coming as a smooth curve above, but below it is kind of a smooth curve. This is because if you develop the cone which is cut, we were seeing the ellipse like shape. So if you cut that ellipse above, it will form like in shape as you have seen on your screen right now. So to make it easier, let's just imagine if it is a complete cone, it would have looked like this. As you can see on your screen, the development of a cone would look like this, but it is being cut. So the cut portion, I'll just bring you the cut portion here. So this portion has actually been removed from the developed surface. Now you are easily able to visualize this. And for drawing this figure, first we will draw the complete development of the cone, and then we will draw this final figure by taking projections, measurements. As the top view is a circle here, we will first start with the top view. First I am drawing the axis line here. So the diameter is 30 mm, the radius is again 15 mm. I'm drawing the circle here. And now I will project these circular lines to get the front view. So this height is 65. Now I will complete this 65 mm. So this is the front view and this is the top view of our cone. Now for the sectioning part, it is mentioned that it is inclined 2 HP and is at a distance of 37 mm from the ground, from the HP. This means I will mark one point here, 37 mm. I'm drawing a line here, and I will take the angle as given in the question from this point as 30 degrees. And this is our section plane. As we have seen in the section of solids in the previous section, this cone has been now removed from this place. But here our main aim is to develop the surface of this cone. That is why I am keeping this for the moment here as it is. I assume that first there is no cutting of this cone and I will try to develop the surface of this cone. That is, again we have to use the formula, that is AB de Villiers into R by S. Sorry, 360 degree into R by S, which means here again the radius is 15 and the slant height is 66, as we did in the first problem of this section also. I'm taking it above again, 66, which is equivalent to almost 82 degree. So I'm taking some point somewhere here, center point. This will be my apex, and this is going to be my point. So for the start, we can take anywhere, but total angle should not exceed 82 degree, which means I need to take this 82 here, and I have to close this figure here itself. So this is your develop the surface of the cone if it is not cut, but here it has been cut, so we need to get more generators here to get the shape of the remaining portion. For this reason, we will divide the circle into more number of parts. As you can see here, it is equally divided into 4 parts, but what we will do is we will divide into more parts. You can divide into 8 or 12 also. So I am dividing this into 12 parts, which means that every angle should be 30 degree. I am dividing this into 12 parts, so I have to take angle of 30 degree. I will mark 30 and 60 first. Again at a distance of 30, 30.
So we'll give names for this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is going to be your 1 dash. This is 2 dash as well as 12 dash. This is 3 dash as well as 11 dash. This point is your 4 dash and 10 dash. This point is 5 dash and 9 dash. This point is 6 dash and 8 dash. This point is 7 dash. Don't worry, just project the lines and mark the numbers. These are very small, which are I think which will not be visible to you. I hope you are following. So from generator to the apex, these are the generators. And now, as this is 82 degrees, we have to divide this into 12 equal parts also. So if you divide 82 by 12, you will get a fraction as so 82 by 12, that's equal to 6.833, which we can take as 7. So I am again setting the compass here and see that here this 0 position is there, this is 10. So in between there will be 5 and this is 6. Just before 7, careful while you take this. Be careful. So this is one part. And now for the rest of them, we need not measure each and every time. We can just set our compass. We can cut the arcs. You have to do all this thing with 2H pencil only, as it is a question in which sectioning is involved. We don't know the final answer yet. So we'll give names. This is O. This is O dash. This is again your O dash. This is 1 dash. If you name it 2 dash, 3 dash, 4 dash, 5 dash, 6, 7, 8, 9, 10, 11, 12, and 1 dash, which will get repeated. So what I will do is this. You need to listen this carefully. From O dash till this first point, I am taking the length. I am cutting arc here and here. The reason I have taken this because this is the first line and this is the first generator. It is the section pin is cutting it here, so we will get point here. In a similar way, this is your second generator. From the O dash, the second generator is passing through this point at this cutting plane. So we need to take the distance, and from again the center, you need to cut this arc. Moving on with the other generators, this is the third generator. Third generator. This is the fourth generator. This is the fifth generator. Sixth generator. Seventh generator. And again these points will get repeated. This 6 dash and 8 dash are on the same line. Uh, the same points will get repeated. 9. This is the ninth generator. As we have divided into 2 whole parts, we are getting more points. This is 11th. And this is 12th. So, with free hand, you need to join those arcs in this fashion. So, and we have to darken this remaining portion only, because this is not part of our answer. This has been removed actually. So, we'll get a smooth curve in this fashion, and we will get all the generator because we have taken them dual generators. We can darken them. This is your actual answer. Hence, our exercise number 6 is completed. Thank you.
So this is the final solution of a cone which has been cut by a section plane inclined at 30 degree to the HP, and this is its surface developed. So this is our final answer. As I have shown you already, this portion here. Now this is the smooth curve like portion here. This is appearing because we have cut here, and you can observe this. This is the lower portion here. You can relate this point and this point to here, and this maximum point, this point you can relate somewhere in the center here. So that is why if you pass through this, it will go in this fashion. Because it is a cone, it will be round, and you can see the generators passing through here. So that is why the distance is changing here, which you can observe in the front view. I have not drawn the section in the top view because this is our main aim here, the development of surface.